Welcome. We're now going to look at the gradient calculation formula found on the front cover of the reference table. Gradient can be used to find the change in field value, and you'll divide that by distance. The types of questions you might be asked could vary, where the application of these two pieces of information would change. And we'll look at an example in a moment. Keep in mind, gradient must always have, your answer must always have units. The units will be based strictly upon the question you're being asked. The units for the gradient formula will vary, again, based on the information you're provided with in the question you're looking at. The gradient formula can be abbreviated G equals change in FV for field value over D for distance. You could even abbreviate the gradient formula with the delta symbol, which stands for change, FV over D. Writing any version of this abbreviated formula will get you full credit on tests, quizzes, the midterm, and the Regents. So let's look at a sample question where you might be asked to apply the gradient formula. Here, they're telling me in the blurb on the top, the topographic map below shows a hill. Points X and Y represent locations on the hill's surface. Elevations are shown in meters. That's important, to know that the elevations are shown in meters. What is the gradient between points X and Y? Well, let's take a look. Before I jump in and get the values of X and Y, I'm going to label the values of the lines on the topographic map. It's telling me here that Y is sitting right on the 300 line, so that's easy. And here I'm looking at a value of 400. So it seems to me that each of these contour lines is worth 20 meters. So I'm just going to take a moment to label. Turns out point X is sitting directly on the 380 line. So with the application of my gradient formula, G equals change in field value over distance, I'm going to now find the change in field value. Because Y is on the 380 line and X is on the 300 line, I'll always put the larger number up front. 380 meters minus 300 meters divided by distance. This is where you'll need a piece of scrap paper so that you can determine the distance between points X and Y. Marking off on my scrap paper point X and point Y. I'm just going to group these items. The grouping isn't working, but if you were to take your scrap paper and then bring it down with the tick marks on it to the scale below, you would find that the distance between the two tick marks was 2 kilometers. So I'm going to take that information back over here and plug it into my gradient calculation. So continuing on, G equals 80 minus 300. 380 minus 300 gives me 80 meters divided by 2 kilometers, which gives me a gradient of 40 meters per kilometer. So when I look at my choices down below, 40 meters per kilometer, definitely represented by choice A. Another example of the type of question you might need to do for gradient would be something like this. The diagram below shows a cross-section of a cliff climbed by a student. What is the approximate average gradient of the cliff? Well, here, they're giving me a bunch of different pieces of information. They're giving me a 700-meter elevation at the top, 400-meter elevation at the bottom, and they're telling me that basically the distance here along this arrow is 10 meters. We always begin by writing our formula. G equals change in field value over distance. G equals, well, if I've got 700 meters up top and 400 meters down low, I'm thinking that's my change in field value. 700 minus 400 divided by the distance, which they're telling me is 10 meters. 300 meters divided by 10 meters gives me an average gradient of 30 meters per meter. Looking at my choices, choice B would be the way to go. I hope you found this helpful in refreshing your memory on how to use the gradient formula.